Hello, today we are going to be talking about the surface area of right prisms, and you're going to find that there's going to be one way to do it that you could use kind of common sense and reasoning to find the surface area of these, and then there's also a more consolidated formula that you can use that has been developed. So you can go one of two ways. So I'm always going to show the way where it's kind of the common sense first. So we've been talking about surface area, and surface area means I'm finding the area of each surface of my figure, and then I'm just going to add them together. It's just that total. So for instance, on this one, you would see that we have a rectangle and a rectangle, and then there's a rectangle in the back. And then I have the two triangles. Now the two triangles are the same. This looks different because for finding the area of a triangle, I need to find the height. So if I look down here, I've got that this is 4 and that this is 4. And we can see from up there that this is 4, meaning that this is an equilateral triangle. But in order to be able to find the area of that triangle, I would actually need that height, where we have that line. It's called the altitude that drops down and hits at a 90-degree angle. And that's what they have here. That's what that dotted line is here. And that is 3.5. So that means that our height of our triangle is 3.5, but that all the sides are the same. All the sides are the 4 centimeters. And we need those to know those side lengths so that we can do our rectangles. Now, since this is an equilateral triangle and this is a right prism, that means that if these are all 4, then these are all going to be 10, that all of my rectangles are actually going to be the same here. So the first thing I'm going to do is I'm going to find the area of my triangle, and the area of my triangle is 1/2 the base times the height. And that means that is 1/2 the base is 4, because that's the side length, and then the height is that 3.5. So it means the area of my triangle is going to be 2, because half of 4 is 2, times 3.5, which is 7. So the area of one triangle is 7. Now I have 2 of those, so I'm going to multiply that by 2. Now the other thing you could see is you're like, I have to multiply by 1/2, and then I need 2 of those. So if I start out like that, these two are going to cancel each other out. I never have to do that half part. I would just go ahead and multiply 4 times 3.5. But no matter what, I find out that the total area for the 2 triangles is 14. And this is centimeters squared, because remember, this is area. Then I have my rectangles, and the area of one rectangle is going to be length times width, which is going to be 4 times 10. And it doesn't matter which order you do that in, remember? And so that's 40, and then I have 3 of those. I have 3 of those rectangular sides. So I'm going to multiply this times 3 so that my area for my rectangles, my total area for my rectangles, equals 120. And then I would need to add those together, so I get 120 plus 14, which is 134 centimeters squared. And that is indeed, I almost wrote that on the wrong line, that is indeed our area, or the surface area. And now we're going to move down to our next shape here. So our next shape is also a right prism, and you'll notice that our triangle is a right triangle. Sorry about the hole punch there. And with our right triangle, with our equilateral triangle, they were all the same, which meant all that our rectangles were the same. With our right triangle here, we happen to we have an isosceles triangle. And so 2 of the sides are 10, but that third side is 14. Now the thing here is that where I see that 90-degree angle, that's going to be my height. So the side of my triangle and my height in this case are one and the same. So in order to find my surface area here, I still have 2 of those, remember. So my area of my triangle, and then I need 2 of those. So I'm going to do 2 times 1/2 times base times height. And so right away we know that these are going to cancel out. So the total area of my triangles here, when I have two of them, so the total area for my two triangles is going to be 10 times 10. So the total area for both of my triangles is 100 centimeters squared. So the next thing that we're going to look at then are the rectangles. Because I have an isosceles triangle, that means that two of my rectangles that make up the sides are going to be the same. And then this big top is going to be different because up here all three of them were the same because all of the side lengths of the triangle were the same. In this case, only two of them are. So the area for the two rectangles that are the same, so that's this down here, this one at the bottom of the shape, and the other one that would make up the side, they are both going to be 10 by 25 and 10 by 25. And then if I were to take a look, this big one up here on the top of it, that we can see the area the side that would be facing us is going to be different. So for those two at the bottom, I've got 2 times the length times the width. So I have 2 times 10 times 25. So I have 2 times 250. So those two rectangles that are the same have an area of, 500 centimeters squared. Now that last rectangle, that big one on the top, there's just the one. So the area of that rectangle is going to be 14 times 25, the length times the width or height of the figure in this case. So 14 times 25 is 350 centimeters squared. And then I want to add these all up. So I've got 100 plus 500 plus 350, which is 950 centimeters squared. So the surface area, if that was a box, I would need that many square centimeters of cardboard to build that box. Or if I wanted to cover it in wrapping paper, I would need that many square centimeters of wrapping paper to cover that box. Our next example down here, we have a triangle where none of the sides are the same, which we call a scalene triangle because none of the sides are the same. So this one's 5, and this is like the base of the triangle. This one right here is 12, and because we have that right angle on our triangle there, this is indeed our height, where this one is our base. This we haven't learned yet, but this is called the hypotenuse of it. This is just the third side of that triangle. And we're going to need that when we try to find the area of this rectangle on the front. So we're going to have two triangles again. So we have two triangles that we're finding the area of. So that's 2 times 1/2 times base times height. Remember, this cancels out, so it's just going to be base times height. So the area of both of our triangles together is going to be 5 times 12. So the area of our two triangles is 60 centimeters squared. And that gives us the area of our two triangles. Now, all of our rectangles this time are going to be different from each other. So this rectangle at the back here is going to be 12 by 14. So the area of rectangle number 1 is going to be 12 times 14, because base or length times width. So the area of rectangle 1, that is 12 times 14, is 168 centimeters squared. The next rectangle is going to be this one up front here, which is 13 by 14. So the area of rectangle 2 is going to be 13 times 14, which is 182 centimeters squared. And then my skinny rectangle over here on the side is 5 by 14. So the area of my third rectangle is 5 times 14, which is 70 centimeters squared. And I'm going to fit that in there, squeeze it in. I'm going to add these all up again. So I've got 168 plus 182 plus 70. And then I've got to remember to add on that 60 from my triangles. And I get a total of 480 centimeters squared. Remember, at any time you can pause this video and see if you can do them on your own. This next one right here, our bases of our right prism are actually hexagons, so they have 1, 2, 3, 4, 5, 6 sides. So how do you find the area of a hexagon? So the area of a hexagon is going to be, finding the area of a hexagon might be something you have not done before. So finding the area of a hexagon, we are going to use 3 radical 3 over 2, and this has to do with the triangles that I could split it up into. If you have a question about that, I can help you with it. Times a squared. So a squared is the side length of the hexagon. So we're going to have 2 of these, so I'm going to multiply by 2. Now, what you might notice is that these 2's are going to cancel out. So now I have 3 radical 3 times 36. So I would do 3 times 36, and I will get 108 radical 3. Now, for our purposes, we need an actual number. So if I put this into my calculator, this is 108 times radical 3. So the reason I can do the 3 times 36, there's like a multiplication sign there. So if I put that into my calculator and I multiply those times each other, I'm going to get 187 and 600ths. And these are going to be units squared. Now the other part are still rectangles. And the nice thing about these rectangles is that they are all the same. So my rectangles, I need 6 of those, like I needed 2 of those. So I'm going to need 6 of length times width. And my length here, I'm going to think of as 6. And then like the height of my figure, I'm going to think of as 19. And so I get 6 times 114, which gives me 684. Now I can just add these together. And I can find out that my total is 871 and 600ths, and it's units squared because they didn't tell us that it was centimeters there. Now there's also, remember how I said there are some special formulas that people have figured out. So the special formula for the surface area of a hexagonal prism is 6 times A times H plus 3 radical 3 times A squared. And you're like, oh, wait a minute. This is basically the same thing. So I end up with 6 times 19. Well, that's what we did here. Plus 3 radical 3 times 6 squared. When I do that, you'll notice that is what we ended up with here after our 2's canceled out. So I'm still going to get 684 plus 187.06, and I will still get 871 and 600ths units squared. Our last one on the back is a trapezoid. I'm going to pause, do it, and then have you turn it back on to check it out. Alright, so go ahead and pause this video and check out the work that's going on up there. We had to find an area and then use that area of the basis times the height to find the volume. And then over here we've worked out the surface area. So go ahead and pause it and check those out.